We have with us Charles Tolman, and he works on large engineering systems. He's also a founding parent of Alder School. And the theme that is the hidden path of technology is a theme that Charles has been exploring for 30 years. So without any further ado, I will pass the word to Charles. Thank you for being with us.
Well, good evening, everybody. Thank you for being here, and also thanks to Lucia and Alder for hosting this, because this is a subject that's quite close to my heart, actually. Having, as you can imagine, I started work programming around 1975, 1980, way back during the PC revolution, and so I've been working. I need to say I've been working with Paul Jenkins a lot on this in terms of studying this technological path in the light of Steiner's work. Basically since the early days of the school, which is where we met when we met up. So this is going to be quite a quick blitz through 30 years of work. I've had to sort of pick primary points. We've been interested more looking into the philosophical path of anthroposophy, which I think Steiner calls is slower but surer. It means that I can be sure that I've got some degree of experience of what I'm talking about. Particularly been interested in terms of Steiner's what he would call epistemology, theory of knowledge, because it actually matches and marries into the technical path. And so really, it's not a case of shunning that technology. It's a case of actually developing the skills to be able to deal with it well. What I'm wanting to do is bring the human backstory as I see it, I think. I'll be talking, a lot of this is drawn from actually working in technology and doing software development, but actually in terms of the skills and capacities you need to develop, they are relevant for anybody who lives in a modern society. It'll become more and more important, because even when you're using a system as a user, you're sort of still working with the system. You're sort of almost programming the system through the channels that the developer of that system has given you. Why have I called it the hidden path of technology? Well, it gets people's interest up, certainly, but there is ample scope for self-deception when you're dealing with technology, whether you're user or developer. And I think it's really important to get a clear sense of what's under the surface a little bit, without going too deep, of what we're dealing with. For instance, there's been a definite corruption of the word in terms of computer memory is nothing like human memory, and vice versa. You know, information processing, they're totally different things. And also but on a more positive note, what I want to do is sort of reveal that there's a link between Steiner's approach to spiritual development, self-development, and technical development. Even if it's not known to the practitioners, even if a practitioner's got no clue about Steiner, hasn't come across him, there is a link between his approach in terms of the theory of knowledge and what you actually go through when you're doing technical work. So the sequence I'm going to go through is I'm going to do a little bit of history to give a sense of how I see we've come to be in this technological society, what sort of ideas underpin it, dealing both in terms of the philosophical history, a little bit of recent technical history, and then more pseudo-biographical in terms of what I see as the path of the programmer going through this at a human level. I'm then going to deal with a bit of the design thought processes that go off, and then touch on how I see that marries into spiritual principles, if you will. And then I'm going to end with some reflections on AI, because I get asked questions about that quite a lot, and also the economics of this domain. Okay, so what I'm going to do is share my screen. I am going to do some slides, so hopefully it won't be death by PowerPoint too much. Okay, so I hope that is just give me a thumbs up if you can see the things. Great, thank you, lovely. So those are my contact details, which I can put up at the end. I've got a website, charlestolman.com, where I put some of this information as well. I haven't updated it for a while, but and that's a short email address. I can put that up later. So where do we start? What happened? What actually has given us the underpinnings to where we are? Well, one view I'm taking here is it can start with the 30 Years' War. Back in the 1600s, there was a real concern about subjectivity of religious faith, because you had a 30-year war resulted in the death of a third of the German population. And there was a real concern. The church was really open to approaches of how is it we can come to be a point of certainty. So there's a real quest for certainty. So, and it was in this time that we had this gentleman, René Descartes. He produced his discourse on method, and he was trying to get clear. We've heard a lot of, I'm sure a lot of us know his basic approach, conclusion, but he was trying to clear the decks of things, of the senses particularly, to try and find a central point where we could be certain about our experience of the world. And so he was talking about, what is it I can be clear of? I'm doubting. There's all this uncertainty going on. That means there's a being that's thinking about this doubt. So I'm thinking, and then there's a being that's thinking, and that's me existing. And that was a central point. So you had this initial separation between the experience of the world and the senses and my thinking. Hence this subject-object split, which is, you can see in the way we approach the world even today. A lot of the ecological issues are due to that split. It's very much about removing the human being, because he was trying to eradicate subjectivity. However, because he was able to get the church to accept the primacy of mathematical thinking as a way to certainty, it gave the foundation for the scientific revolution and then the industrial revolution, leading us on to our modern technological society. So this has been a 300 to 400 year project. The next person I want to highlight is this gentleman a bit later. Now we're getting into the 1800s a bit, late 17, early 1800s. And Goethe was raising some concerns about the scientific method. Basically, the scientific method is you do some observation, you come up with a hypothesis, you then come up with an experiment, and then you test your experiment and refine your hypothesis. And what was happening was that it's very easy to reduce the observation to a small amount and over-hypothesize. So he was raising the flag and saying, we're starting to impose our thinking onto the phenomena. And so he coined these terms: one, exact sensorial imagination, and two, delicate empiricism. So he was looking at the world of plants. He was looking at the natural world and trying to understand how the plants metamorphose during their growth, and saying it's fundamentally important that we develop an inner set of faculties such that we can imagine that process. It's not fantasy, it's not an imaginative fantasy process, it's an actual calm, clear thinking and in pictures that match to the phenomena you're looking at. And also in terms of not imposing your thinking onto those phenomena, this concept of delicate empiricism, where you gently approach the idea. Now, I mention these two because they are fundamental in any technological work. Number one, the exact sensorial imagination. When you're developing a system, you've actually got to imagine how it's going to work, or else you actually can't do the job. You've actually got to build a system in your head and understand how it's going to work as you're programming it into a system. Yes, the system will mirror it back to you, but you've actually got to have that faculty of imagination. Secondly, particularly when you're debugging a system, you need to have a delicate approach to it. Very frequently, something goes wrong, and then you go and say, oh, it's that, and you fix that, and you modify it. It seems to work, but it comes back and bites you later. So there's a very strong link here to the technical path already with Goethe. And here we're talking about the education of subjectivity. So there's been this wish to become objective, and actually it's not possible. We are embedded in the world. We cannot take ourselves out of the question. One of the interesting examples of this for me is even the Cartesian coordinate system. Descartes comes up. I don't know if you can see my three fingers. I've got the x-axis, the y-axis, and the z-axis. fundamentally objective point, you would think, in terms of how to measure spatial positions. However, that's embodied in our physiology. If you take the ovum, the fertilized ovum, when the cell division starts to happen, it actually happens on those three axes. You have the left, right, you have a split down left and right, you have a split front and back as a second division, and you have a split top to bottom as a third division. So I find that a very good example of how you actually can't get rid of the human being, you can't get away from that subjectivity. So the best thing you need to do is educate it. I want to take a little bit of a sidebar here into handling doubts, because this is a fundamental issue with any technological society. There are three ways you can see about handling doubt. If you accept the fact that we are subjective beings and that we can't get to know the thing in itself, which is something that Kant came up with, but Descartes, that split, trying to get rid of the uncertainty, you can handle that in one of three ways, I consider. It's also a good chance to get a bit of Monty Python up here. You can run away and say, well, I'm not even going to try and get to know something. I'm going to be just atavistic. I'm going to live into the world. And that's been a valid approach, particularly something with from the Eastern traditions, in terms of you're just living into the world. You're not going to be worrying about generating new knowledge necessarily. For the Western path, we tend to deal with leaving it to experimentation. This is now we're getting into that problem, that realm where, as Goethe was saying, it's too easy to impose your thinking on the phenomena you're looking at. So you've got the sledgehammer, which is your experiment, to crack the nut, which is your nature. And you need to be careful with making sure you do enough observation and staying with the observation, which is a fundamental point that Goethe was talking about. The third way is being able to stay with the not knowing. This is really hard. It's very uncomfortable, but it is a necessary capacity to learn to develop. It requires a strong sense of self. Now, I will come back to this because this is also a core skill that is needed when you're doing any technical work or dealing with technical systems. You've got a deadline, but you may not know the answers to getting to that deadline. Okay. Coming back to the progression of philosophy a little bit, we now come to Steiner, because Steiner was the editor of the Goethe archives in Weimar until 1896, and it was in this time he produced his philosophy of freedom. And the philosophy of freedom was primarily trying to look at understanding how we come to know anything and saying, is that something that could be used as a foundation for the scientific method? Basically, rather than taking science to understand how we know anything, Steiner was saying, no, you've got to develop your inner faculties first. Now, he took Goethe's ideas in terms of Goethe being able to develop this delicate empiricism and exact sensorial imagination, but Goethe was interested in the plant world. It was Steiner who said, we can actually turn this on our own thinking. We can bring this inside ourselves. So we are looking here at perceiving how we are thinking and developing that skill of being able to have, if you like, a delicate empiricism in our thinking. And so this was also tied in with inner freedom, because hence the philosophy of freedom, although in German it's freeness. This is the problem with language, because the English language is very noun-oriented, where German is much more verb-oriented. But basically, if you get to be clearer about how you know things, it means you can be much better in your self-knowledge, which gives you more freedom. That's that inner freedom that we're dealing with. And so we're talking about, he talks about these concepts of imagination, inspiration, and intuition, which I'll come back to later. I'm just going to pass through them at the moment. But what Steiner was mainly there to talk about was the development of non-physical substances. And so this is where this relates to a spiritual path, if you will, saying we are given our normal physical senses when we're born, but he was seeing it as the evolution forward is for us to develop these inner non-physical senses. So that's a quick blast through some of the philosophical history, how we've got to here and how I see Steiner fits into that. In terms of technical history, so here we have, on the top left, we have von Neumann. Some interesting little points here about, he developed the architecture of computers that are, has remained unchanged to this day. All of the computers we're having this meeting on, the mobile phones, the tablets, are using what's called a von Neumann architecture. Basically, that's where you can have a program and you have the data it works on. So you have your app, which you can load into the same memory as the data that that app is going to work on. And he didn't patent that, but a little interesting snippet here is that he didn't patent it because he knew there was a problem with this architecture, that you'd spend more time transferring the data around everywhere than you would be processing it. So when you're sitting there with your spinning wheel going, you're sitting on something that was developed in 1944. The guys knew it then, and hence didn't patent it. But what happened was other engineers came to look at the system and then went away and built their own versions, patented that, and started their own companies, Sperry, Univac, all the big guys, and froze the idea. So this is where economics can freeze the idea. The reason I want to point that out is to touch back a little bit to what Joy was talking about in her talk last month, about the play is the work of the kindergarten child. Well, I would go further, actually. I would actually say that play is the work of the adult. In this situation, your existing computers have a foundation in play, the personal computer revolution. Like myself, many early programmers were amateur electronics enthusiasts or radio ham. So we used to go to radio ham meetings and be drooling over the latest technology and toys that some people were building. Oh, it's got 64K of RAM. My goodness, it's full. That's all you could get in those days. And this is an early computer there. Even the Apple was on, the first Apple was that sort of meeting on the west coast of America. And many of the early PC programs were games. So what I'm highlighting here is the fact that there's been a strong foundation in play in this whole industry, even to this date, with the development of the free software movement. But what are we playing with? What is it that technology and tools actually are? Well, they're amplifiers. They amplify our capacities, or they give us capacities we don't have. So you have the Industrial Revolution, which is devices to amplify our physical capabilities. They're external problem solving. You could play with a gear. I mean, I did take a gearbox apart, but basically you could have a look at a gearbox and you could take its bits apart physically and understand, oh yes, it sort of works like that. You could mess around with it. It's an external problem. And that was what was happening with the Industrial Revolution. Suddenly we've gone to information technology, and that's devices to amplify thought. Not quite our thinking, but thought. And that means there's been a transition from external problem solving to inner problem solving. Now, this is a significant threshold crossing, which gives us a lot of problems in terms of managing this. Suddenly, 80% of the job is happening in my head when I'm working on this. And this gives rise to a lot of problems in terms of how do you manage this? And it's fair to say that there is still a disconnect between those who are managing the technical process and those who are actually doing the work of programming the systems. It's much better managed these days, but there's still issues of how can we deal with this in an economic context? And that's because we're really in that arena of play. So this brings me on to some thoughts about how does a programmer go through their career, based on my own experience, obviously, but also based on talking to other programmers. I've sort of split it down into three sections: novice, journeyman, and master. Originally, you get involved with this because of there's a fairy glamour. There's almost an enchantment of playing with the toys. I want to play with the toys. So you have the novice phase. I I like my gliding. I haven't done much recently, but you'll see, this is why we've got some pictures of gliders here. The novice phase, you have little knowledge of tools. Your learning process is very rule-based. You're learning to do this, and then this, and this, and this. So you have a sequence of instructions about how you're going to learn something. Any complexity of a software you're writing is, it's low compared to the complexity of something that's close to a real world problem. So you have something that is very simple, but it's also probably very brittle. You're aware of your own limits, so that's a good thing. So we'll come back, you'll see this issue of awareness is quite important to me, but you're unaware of your own process, about how you're solving the problems. Okay, so we probably spend a number of years in this phase, depending on how one's education is. Things have moved on. It makes it very difficult because now the technology has moved so far, this can take quite a while. This is the dangerous phase, what I call the journeyman phase. So this is where you have a better knowledge of tools. You've got an abstract thinking, and I'm calling it abstract because now what's happening is you're more thinking about what tools can I use, what bits and pieces can I've got all these lovely little toys to play with, what can I use to put into the system? And it's easy to overshadow the problem complexity with the complexity of the software you've generated. This happened to me back in 1985. And what happens is that the system gets away from you. It's a sort of sorcerer's apprentice moment. Very, very scary, total panic. But what characterizes this stage is that initially you start out with quite a lot of optimism and a bit of a technical arrogance. You like to prove how clever you are. And so what's happening is you're making something that's very complex given the problem that you're trying to solve. Characterized by this lack of awareness about one's limits and the process you're using to come to solve a problem. One of the truisms here is that the complexity of thinking you require to fix a system has to be more than the complexity of thinking you used to design it. So therefore, if you go right to the limit of what you can handle when you're designing it in terms of the complexity, by definition, you're not going to be able to fix it. You're going to have to pull in other people to help. Now, some programmers can spend their whole career in this stage. I actually did have a colleague who didn't get out of this stage even by the time he retired. And the issue is that you need to learn about these concepts of delicate empiricism, particularly in terms of not pushing your own ideas onto the problem, because you're going to be amplifying your capacities, but you'll also be amplifying your mistakes. Now, once you've got it wrong time and time and time again, we get to this stage. Yeah, I call it the grumpy old programmer. Okay, I could call it the master. I hesitate to call it the master, but there you go. Here you have good knowledge of tools. You have a context-based thinking where you're looking at the problem a bit more as a whole, although you can highlight particular risk points and have to go into these particular areas to check that I know what solution that's going to require. I think this can take about 10 to 15 years to get, but it's happened because you've learned how often you're wrong. I mean, we're not talking tens of times, we're probably talking 100 times. And the complexity of the software you're coming up with is roughly the same as the problem. Actually, the code should look probably a bit more like the novice code, but you bring out the big guns when you know what you're doing. The main issue here for me is the fact you're much more aware of your own limits now. You're trying to find essences. You're trying to find the minimal set of tools you can use to solve the problem, what I like to call Japanese garden software. You're much better able to handle not knowing. One anecdote I have here is we once had a younger programmer who had to write some software to drive an external videotape recorder from a computer. He took 3 months and didn't manage to do it. Another colleague who had a bit more experience and had gone through this awareness point did it in 3 days, succeeded in 3 days. So you had a 30-to-1 differential, because you had someone who wasn't aware about their process and their limits compared to someone who was. And this is not uncommon, it's not atypical. Indeed, there was a report, a study done by the Open University about the successful software teams. And generally, it means you've got someone who is coming from left field. They do Tai Chi or yoga, or have some weird interest in philosophy, like maybe Rudolf Steiner, yes? And that helps make a successful team. So that's a little quick push through how I see the issues involved in the path developing a programmer.